All right, so Workplace 20 students, we are going to talk today about section 4.2. This is probably one of the most challenging sections in the entire course. So I know you guys have, we've already been through this already, but this is a bit of, we're going to do some extra problems here from the workbook. Here's some real world, three-dimensional or slash two or more triangle problems, okay? So working with triangles is one thing, but when we have a question where there are two or more triangles involved, what it means is that we're going to have to, we're going to have to accurately represent the situation with a diagram if one is not given, and we'll talk a little bit about that. But you should draw a diagram, okay, so you can see what you're dealing with. And B, we have to understand that when we have more than one triangle, there's often going to be more than one step as well to find the missing side. So a quick example for this one here, solve for x and y. Well, if you look at x and y here, those are pieces of this triangle right here, the angle 68, but we're only given an angle. We don't have any other side or anything. So to solve for x or y is going to be impossible here. What we have to do is we have to start with this other triangle right here and realize that I have an angle, I have the adjacent side, and I can find the hypotenuse of this right triangle. And so, as we've already gone over, there's going to be multi-steps, and you're going to have to solve for certain pieces first, and then use those pieces to solve for another piece of the question, okay? So they're multi-step questions. Now, how many of you have been through 4.2 already? I know some of you have, okay? Has anyone not gotten to 4.2 here yet? Okay, maybe, and you're in the middle. Okay, good, that's fine. So this would be good if this is your first time through this as well. This is meant to be a bit of a review, but that's totally cool. So if you don't have these out already, get your 4.2 out, and you may not have some of these examples because I think you just have the practice problems, some of you. But anyways, so I'm going to skip ahead to this question, and I would like you to put this on a piece of paper. I'd like you to take a moment to sketch out this diagram, and then we'll read it together. We'll interpret the diagram. So just take a moment to sketch that diagram out. All right, so I'm going to talk about this question here. We're going to talk about the diagram that's given as well. It says, from the top of a 200-meter tall office building, the angle of elevation to the top of another building is 40 degrees. Okay, so that first sentence right there, notice that this is a 200-meter building. And from the top, the angle of elevation, so you should remember what an angle of elevation is. From the horizontal, we are elevating up, okay? So it would be the angle measured from the horizontal up, 40 degrees. And so that's where we see on the diagram, this is a 40-degree angle right here. See that? Okay. And that is a line of sight, or whatever, the angle of elevation to the top of another building. So we're going to draw a line where this reaches the top of building 2. Now, the angle of depression, okay, so that is from the horizontal, the angle of depression goes down from the horizontal, right? So depress means to push down or to be down. So the angle of depression to the bottom of the second building right here is 25, okay? So if you were not given this diagram, you would be expected to sketch this out so that you can kind of see what's going on. And here, when you do that, knowing that the horizontal forms a 90-degree angle with the second building, we can assume these buildings are perpendicular to the ground. So we can see that we have two triangles, right? We have two right triangles. Here's one and here's two. So this is a problem definitely involving more than one right triangle. The question says, how tall is the second building? So how tall is the second building? Well, what we're going to need to do is we're going to need to find probably this side and this side of these two triangles. Okay? So can we do that? Can we do that? Well, do you see anywhere where either this section or this section is given in the question? Does anyone know one of those two sections already? Yeah?
Because it's a right angle, the 200 meters.
Oh, okay, very good. So what you're noticing is that this 200 meters, which is the height of this building over here, because this is a horizontal, that means that this section right here is also 200. Okay, so that we can start with. And as a matter of fact, it might be a good idea to label that on your diagram, 200. So now I have 25 degrees and I have an opposite side of this second right triangle of 200. I'll just redraw that out here so it's a little less confusing maybe, but so this is 200 and this is 25. Everyone see that? Okay. All right, so how does that help us? Well, we need to find this second section right here, which, boy, I don't have a lot of information. I just have the 40. Any ideas on where to go from here? Yeah.
You use tangent, then you can use 200 meters over the adjacent side to find the adjacent side.
Okay, very good. So we can find this length right here, which is equal to, in this other diagram I drew, which is equal to this length. And of course, this is the opposite side. And this would be to the angle 25. This is the adjacent side, isn't it? So if we remember, so, ka, toa, right? Opposite and adjacent are the tangents. So you're right. So tan of 25 degrees equals the opposite side over the adjacent side. And for now, let's just call that A for adjacent. Because it's unknown, we don't know it, but we can solve this. Okay? All right, so what is A? Go ahead and solve A here right now. Take a moment and solve for A. So A should be 200 divided by tan of 25, which should be 428.9. 428.9. So if you didn't get that answer, check your calculator. All right. You may have to be in degrees, not radians, to get that answer. So 428. Okay.
Wait, so what did you do to get it?
200 divided by tan of 25.
Oh,
Okay. So the A gets multiplied to both sides, and then you divide by tan 25 to solve for A. All right. So remember, in a simple proportion, numbers can travel diagonally across the equal sign, right? They can just kind of move up there and go. And when they go up top, they're multiplied by that on the other side. When they go to the bottom, they're divided on the bottom. So 428. Still in trouble, 428? All right, so as we keep going, now we have, and I'll draw the second, I'll draw it in red here. I'll draw the second triangle. There's 40. Now I have 428.9 or 429 if you want. And then we can find this one now. So this is opposite side. So we can find this length right there. And of course, opposite and adjacent, well, that's tan again, isn't it? So I could set up a tan ratio here. Tan of my angle, which is 40 degrees, equals opposite side, which I don't know, divided by adjacent, 428.9. So you see, in questions like this, you need to solve one piece and use that to solve another piece. Multi-step, that's often the way it's going to go. So the opposite side here is equal to tan of 40 times 428.9. My calculator's frozen. Okay, so 359.9 should be your answer for this this top section. So 359. All right, so how do we solve this problem now? Well, we've got the two pieces that we're after. You simply add these two and your solution should be 359.9 plus 200, which is 559.9 meters. Make sure you have your units in there, and that is the answer to your question. Okay? So that's 4.2 number 4 from your workbook. That's angle of elevation, angle of depression question there.